this argument really isn't that unreasonable in terms of trying to argue why we should not have nuclear energy. And the point is that the waste, by regulation, has to be put in a safe configuration for many, many thousands of years. And the reason why I bring this up is that, yeah, we can do that. And here's an example of why. I have here these samples of salt that came from the waste isolation pilot plant. Now you might say, who cares about some salt? Well, the reason why we care about this is at the WIPP, the water evaporites, the regular sodium chloride and then calcium sulfate and other evaporites are about a mile thick there. And the cross-sectional area of that deposit, it's bigger than many Western states. And so the geologists tell us this is incredibly stable, and it's easy to see why. You've got this phenomenally huge salt deposit that is going to preclude any kind of water transport or any other kind of material transport for a very long time. The age on these, the age estimate is about 200 million years, and it's expected to stay stable for a lot longer than that, given the size and the location. And so the key is that if you have good geology like that, it's not difficult to do this. In fact, it can actually be done cost effectively. So it's easy to see an argument like this and say, oh, well, if that's true, then we can't do nuclear energy. There's no way to do this. But the truth is that there is. And WIPP is operating now, and it has been since 1999, and it's got a stellar safety record. Even the worst case things that have happened in a way that was controlled and was mitigated by the safety features that they have. As expected with any facility, when you have an accident, you would like to hope that the accident prevention mitigation is sufficient to protect everybody. And that's what we found at WIPP. And so it's really quite a success story. I hope that helps.